OpenEdge database performance tuning really starts at the design stage. The tool you use to design a database is the structure description file. In this video, you'll see an example of a .st file that embodies 5 best practices of database design for optimal performance. Let's take a look at the .st file for a database called ATM. This database is used to support a sample application called the ATM Benchmark Kit. The first best practice of database design is to distribute the before image, application data, and after image storage areas across different disks. Notice that in our .st file, the BI area is placed on disk R, the application data area is placed on disk S, and the AI area is placed on disk T. By distributing the BI, application data, and AI storage areas across different disks, you will incur less disk contention and enjoy better performance. You would achieve even greater performance if you put frequently accessed areas on dedicated fast disks. The second best practice of database design is to place application data in separate storage areas, each area dedicated to its own table or set of tables. In our example, the account data area is used to store just the account table, and the bank data area is used to store both the branch and teller tables. Organizing application data into separate storage areas improves performance and allows for finer-grained performance tuning and greater ease of administration. The third best practice of database design is to use fixed and variable extents effectively. Fixed extents are pre-allocated and pre-formatted, so writing to fixed extents is very efficient. Variable extents grow dynamically and are best used for capturing overflow data. Writing to variable extents is less efficient because the space needs to be allocated and formatted. For each data storage area, you should use at least 2 fixed extents and 1 variable extent. In our example, the account data area has 2 fixed extents, each of which has 51,200 K. It also has a variable extent without any specified size. The fourth best practice of database design is to choose the best allowable number of records per block for each storage area. To do this, you must identify the mean record size for the representative table of the area, calculate the optimal number of records per block, and then pick the best allowable number of records per block for the area. In our example, based on our calculations, we picked 64 as the best allowable number of records per block for the account data area. The fifth best practice of database design is to use Type 2 storage areas. Type 2 storage areas provide a number of features, such as clustering, that reduce block fragmentation and scattering and allocate space more efficiently. For best performance, you should always use Type 2 storage areas for application data. In our example, the account data area uses Type 2 storage area with 64 blocks per cluster. Note that Type 2 storage areas are required if you need to implement advanced database options such as transparent data encryption, multi-tenancy, or table partitioning. You have now seen an example of a structure description file that embodies 5 best practices of database design for optimal performance. In the next video, starting an OpenEdge database for performance, you will learn the steps involved in starting a database for best performance. To learn more about database performance tuning, take the course Progress OpenEdge Database Performance Tuning.